Welcome. In this video, we're going to discuss some learning targets that are related to atomic structure. So we're going to think about subatomic particles, what isotopes are, and how to find some key information from the periodic table. So first, let's talk about the subatomic particles. So these are the particles that make up an atom, and they are the proton, the neutron, and the electron. Protons have a positive charge. Neutrons are neutral. Electrons have a negative charge. So often we will use these symbols over here to represent those subatomic particles. The protons and neutrons are found in the nucleus, which is in the center of an atom. It's this small, dense area that contains all of the mass. So notice that protons and neutrons both have equal masses. And then the electrons are in the area surrounding the nucleus. So notice how in this picture it's drawn, it kind of looks like they're orbiting on these rings. So these areas where the electrons are in, we can call these shells. So sometimes we refer to them as shells. Sometimes we use the term energy level. Sometimes we use the term orbit or orbital. So those would all be okay terms to use for where the electrons are. And we'll notice the electrons have a really small mass compared to the protons and neutrons. So the electrons have mass, but it's just really small compared to the rest of the atom. So we tend to ignore it. So when we try and find the mass of an atom, we just look at the number of protons and the number of neutrons. Those are the two subatomic particles that determine the mass. The electrons on the outside, they end up being super important when we're considering reactivity and other properties, because the electrons, they're on the outside of the atom. So they're the ones that are interacting with the surrounding world. So a lot of time in chemistry, we'll focus on what the electrons are doing because they're involved in bonding and things like that. Okay, so now let's look at the periodic table and what information we can find there. So on a periodic table, the atomic number for an element, that tells you the number of protons that are in a nucleus of an atom of that element. So for example, this is telling me that all atoms of zinc have 30 protons in their nucleus. And each element has a unique atomic number. So that is actually what makes zinc zinc, is the fact that it has 30 protons. If it had 32 protons, it would not be zinc anymore. It'd be a different element. And atoms are neutral unless told otherwise. So later on, we'll talk about charged things, but we call those ions. Right now, we're just talking about atoms, so they're neutral, which means the positive charges are equal to the negative charges. And remember, we said here that protons are positive, electrons are negative. So in order for an atom to be neutral, the number of protons needs to equal the number of electrons. So if we're looking at the periodic table, what we know so far is that zinc has 30 protons, and it's also going to have 30 electrons. The protons and electrons are going to be equal. What about the neutrons? Well, there's this one other piece of information here on the periodic table, and it doesn't directly tell us the number of neutrons, but we can use it to kind of figure out how many neutrons an atom might have. So this mass, this number given on the periodic table that tends to be a decimal, that's known as the average atomic mass. And we'll find out later the reason why it's an average is because there are actually different versions of a certain element out there that would have different masses. So for example, with zinc, its average mass is 65.39. That's because there's some different versions of zinc. Some of them weigh 65, some of them maybe they weigh 66. So this is an average mass. A mass number is slightly different. The mass number is like the mass of one single atom, and we find that by taking the number of protons plus the number of neutrons. And since, let's look at potassium, the average atomic mass is 39.09. So I'm going to assume that the most, what I'm going to do is I'm going to round this. I'm going to round it to find the most common mass number. So since this number is really close to 39, I'm going to assume that most atoms of potassium have a mass of 39. And we said earlier that the protons plus the neutrons must add up to the mass. And I know that potassium has 19 protons because that's the atomic number. So my number of protons, 19, plus my number of neutrons must equal 39. So I can now figure out how many neutrons I must have in my atom. That looks like it's 20. So the way you find your neutrons basically is you take your mass minus the number of protons. So 39 was my mass, protons 19, subtract those two, I get my number of neutrons. So let's go back and finish this off with zinc. We were talking earlier about zinc. We know it has 30 protons, 30 electrons. How many neutrons does it have? Well, I'm going to take the mass, which is 65, minus the number of protons, and that'll give me 35. So it looks like an atom of zinc is likely to have 35 neutrons in it. There's some other patterns with atomic structure that are related to the periodic table. So we might notice that when you're looking at the periodic table, the based on what row an element is in, that will tell you how many electron shells it has. And the column an element is in will tell you how many electrons are in the outermost shell. So for example, if you look at iodine, iodine is down here. It is in row 5. So that tells me that iodine has 5 shells of electrons in it. And it's over here in column 7. So it's got 7 electrons in its outermost shell. So summary, the protons and neutrons are in the nucleus. The electrons are on those shells, rings. Sometimes we even refer to them as clouds surrounding the nucleus. The number of protons is equal to the atomic number on the periodic table. The number of electrons is the same as the number of protons because atoms are neutral. And then the number of neutrons plus the number of protons gives you the mass number. So we can use this relationship to figure out how many neutrons are in a given atom, or to figure out the mass if we know the protons and the neutrons. So now let's talk about isotopes. So isotopes are atoms where you have the same number of protons but different numbers of neutrons. An example would be carbon. So you may have heard people talk about carbon 12 or carbon 13 or carbon 14. What these are all versions of carbon. What makes them carbon is they have the same atomic number. So they all have 6 protons. We'll talk later about what these symbols mean. But they're all carbon because they all have 6 protons. But what's different is they have different numbers of neutrons. So if you've got 6 protons and 6 neutrons, you got a mass of 12. If you've got 6 protons and 7 neutrons, you've got a mass of 13. If you've got 6 protons and 8 neutrons, you get a mass of 14. So notice how this number matches this part of the name here. So we name isotopes based on their mass. So if we say carbon 12, that means carbon with a mass of 12. And if you look on the periodic table, we see that the symbol, the element symbol for carbon looks like this. There's a 6 at the top. It's the atomic number. They all have 6 protons. And then the average atomic mass is like 12.011. So since the average mass is really close to 12, what that tells us is that even though there's a variety of carbons out there in the world, you could have mass 12, 13, or 14, the average mass of all the carbon atoms in the world is awfully close to 12. So that tells me that carbon 12 is probably the most common variation found in nature. It's the most common isotope. And isotope notation, the way you name an element isotope, like we were just noticing, is you name it by its mass. So like carbon 14 means carbon with a mass of 14. And then when you write a symbol for an isotope, the mass number goes on the top and the atomic number goes on the bottom. And they would both go on the left-hand side. So this is how you'd write carbon 14, the symbol for it. So mass on the top, atomic number on the bottom. And finding the average mass. So if you want to calculate what the average mass of an isotope is, you'd have to know how common each of those isotopes are. So if we look at an example, boron, it turns out 20% of boron atoms in the world have a mass of 10, and about 80% of them have a mass of 11. So the way that we can find an average here, since they're not equally common, I don't want to just say 10 plus 11 divided by 2, because I don't have equal amounts of these two masses. Okay, but what I do have is, I know 80% of them weigh 11, 20% of them weigh 10. So the way I can find this, it's called a weighted average, is I can take 80% of 11 and 20% of 10 and add them up. And notice that my average, as a result, is a little bit closer to 11 than it is to 10, which makes sense because more of my borons weigh 11 than 10. So this is kind of a general formula for how you go about doing that. And here's what this looks like on the periodic table. So we'll notice on the periodic table, boron has an average mass of 10.81. And that's because about 20% of them, boron atoms, weigh 10, 80% weigh 11. Notice it's not exactly 10.8. That's because these numbers aren't precise there, but they're pretty darn close. And remember that these numbers are the mass numbers. So boron 10 means boron with the mass of 10. Boron 11 means boron with the mass of 11. We can then think about how many neutrons are in each of these isotopes. So boron 10 has 5 protons and 5 neutrons. Boron 11 has 5 protons and 6 neutrons. And this version of boron is the more common version. I know that because the average mass is closer to 11 than it is to 10. So this is close to the average. So some sample problems here. First of all, how many protons, neutrons, and electrons does bromine 80 have? Okay, so the protons is up here on the atomic number. So it's got 35 protons. The electrons are equal to the number of protons, so it's got 35 electrons. And then the neutrons, we take the mass minus the protons will give us the neutrons. So it's 45 neutrons. Because the protons and the neutrons have to add up to the mass, which that number right there is the mass. Okay. I did these out of order. So this one, what is the most common isotope of bromine? Is it bromine 80 or bromine 79? So there's 2 versions of bromine out there in the world. Let me erase this for a moment so you can see it. And it looks like, so bromine 80 or bromine 79, it looks like the average mass is closest to 80. So I'm going to assume that bromine 80 is the most common isotope of bromine. It is closest to the average mass. And the last question, what's a symbol of an element which has 17 protons and 18 neutrons? So I'm going to do is I'm going to look up on a periodic table, and I'm going to find one with the atomic number of 17. That looks like it is chlorine. It's got 17 protons, and then the mass is 17 plus 18. It is 35. So this would be the symbol. If I were to write out the name of it, I would say chlorine 35. All right, thanks for